In this example, we're being asked to compute what V0 is, given that the input voltage is 0.1 volt. And if you take a look at it, this is not exactly an inverting configuration because we have this extra resistor in here, so we have to do the general analysis. So I'll put my assumption in here. My assumption are the following, that the IN is 0 and the IP happen to be 0 in here. And VP is also 0 because it's connected to ground. That means the VN in here is 0. So that leaves me with a couple of points in here. So I'm going to name this 1, this 2 here. So the voltage associated with it is 2. This should be 2. Okay. And then here I'm just basically making it 0.3 in here. So taking a look in here, I have the voltage in here. What I'm looking for is V0, but I don't have the V2. So what I don't know is V2 and V0 in here. So that means I have to write at least a couple of equations. So I need 2 locations where I should be writing nodal analysis. I can't write nodal analysis in here because I don't know what the current leaving the operational amplifier is. So that leaves me with a couple of points, which one in here, one in here. Well, I technically know the voltage in here, so that will be helpful. So let's start with that 0.1 in here, since I know the voltage already. So I'll start in here, and that basically is Vn minus 0.1 volt divided by the R1, which is 1K, plus it will be Vn minus V2, the thing I'm looking for, divided by 5 kilo ohm, and that should be equal to 0 because In is 0. Now I'll substitute my Vn is 0 because it's the same as Vp, okay? So that leaves me with the following, negative 0.1, negative 1 divided by 5 V2, and that equals 0. So that means V2 is equal to, so V2 is, I believe, negative 0.5 volts. Okay, so we know what V2 is. Now we have to write nodal equation here. Even though we know what V2 is, we'll have to write the nodal equation here just so that we know what V3 is. Okay, so V2, that will be V2 minus Vn, which is 0 divided by 5, plus V2 divided by 1 kilo ohm plus V2 minus V0, the thing we're looking for, divided by 3 kilo ohm equals 0. So I substitute the value of V2, which is negative 0.5, divided by 5, plus V2, which is just simply negative 0.5, plus negative 0.5 divided by 3, negative V0 divided by 3 equals 0, and that gives me the value of V0 to be negative 2.3 volts. Okay, and that's about it. That's everything we need to know. Now, if I asked you to compute what the value of I0 should be, let me just do that here. You can simply tell me, well, it is the current going through this particular resistor. So let's figure out what the voltage across here. That's simply V0 minus V2, okay? And that means I0 is just simply V0 minus V2 divided by 3 kilo ohms, and that V0 happened to be negative 2.3 divided by negative 0.5 divided by I believe it's 3 kilo ohms, and that will be the exact resistor in here, 3 kilo ohms, and that will be negative 0.6 milliamps, and that's how much is the current leaving the operational amplifier is.